Hi everyone. Today we're going to be taking you through automation of Microsoft SQL Server on Nutanix, utilizing a few of our enterprise cloud features. Here is our Prism Central dashboard. We're going to open up Calm, and we're going to open up our SQL 2016 standalone blueprint that we have custom created. You will see in here that we have a single VM, and an important thing to note with Calm blueprints is that we are able to specify user input using variables. So here you can see things such as a database name, a domain name that we'd like to join the VM to. We can also specify credentials that we can pass through in order to execute some of the actions in the environment. So for example, our domain administrator credentials. We're going to specify the restore of a database backup file as part of this deployment. So you can see the UNC path to a database backup file. Let's save this blueprint. And we're going to launch this thing. When we launch, we need to specify a few things. So the name of the VM that we'd like to create, as well as the application name. We're going to keep these things the same. And you'll see those variables are pre-populated with default values. So we click create, and off we go. So it'll now go and begin provisioning a database virtual machine. We're speeding up time here. Let's log into our Prism element to verify that Calm is creating that SQL VM. So we search for SQL, and you will see that SQL VM03 has been created. So let's explore this blueprint a bit further. So we have a single VM. If we go and configure the install process, we can see all the scripts that are being executed here. So this is a Windows machine, so naturally it's PowerShell that's being executed. The first step is to wait for the virtual machine to sysprep, so that takes about 2 minutes. We then go and disable the Windows firewall with that command there, PowerShell command. We then request that the VM is joined to the Active Directory domain, and we pass through the variables from the front end that the user specifies. Important to note that that's how we can utilize variables in our blueprints. We then need to wait for the machine to reboot after joining the domain. Then we're going to format the disks that we have specified for this VM, so we're giving it 4 disks. We also want to add the local administrators to the system administrators group in SQL Server. So there's our script to do that. Following step will be to install SQL Server, and we're going to specify a bunch of switches there to implement some best practices. Then we have a SQL script that we execute, which will also apply some best practices, which we'll come back to later. We enable some PowerShell remoting. We set the service account for SQL Server to start up with. We'd like to use a domain account for that. And the last step we're going to do is run some SQL to go and restore the database onto the database instance. This VM deployment typically takes 10 minutes to run, so we're speeding it up so that you don't have to sit through that long process. So 10 minutes to 10 seconds. Calm will then change status of the application from provisioning to running. That's confirmation that your application has been deployed successfully. Let's jump across to the Prism element again and search for our SQL VM. We're going to launch the console now so that we can see what's going on in that virtual machine. Speeding up time again. And here we have our VM. So as you can see, there are a bunch of properties that were assigned to this virtual machine as part of the customization process. So it's been named correctly as we specified from the variables. It's been joined to our ntnx.local domain. The firewall was disabled as part of the process too, so that we don't have any firewall challenges. We can verify that the disks were added correctly and formatted as we expected. So there they are, the 4 disks as we specified. They've been formatted correctly. You'll see that there are some files on there already. As an example, SQL installation specified 4 temp DB data files. There they are on the disk. Let's launch SQL Management Studio. Speeding up time again, this will be the first time the application launches on this VM. Connect to our instance, expand the databases and see that we have ERP-DB. It's a blank database. It's 15 gigs in size, but restored from basically an empty database file. You can see that some of the best practices we applied have come through. For example, we set the limit of memory to only use 6 gigabytes of memory as a maximum for SQL, because our VM only has 8 gigs. If we go down here and we have a look at the max DOP is set to 2, and our cost threshold for parallelism is set to 50. Those were parameters we specified. We also set optimize for ad hoc workloads to true. And lastly, we enabled the default setting for the backup compression on SQL Server to enabled. You can also see that we've got the default paths for the database mapping back to those drives that we added earlier in the deployment process. So I'm going to go and delete the database now because I want to show you how we will use another product to clone a database from a source server onto this new SQL Server we created with Calm. This is Nutanix Era, which is our database management tool. We're going to demonstrate some copy data management functionality on Era. So you can see we have a couple of databases registered in here. One Postgre and one SQL Server. You'll see here from the dashboard, you can see sources that exist. You can also see how many clones you have in your environment of those databases. You can see which cluster the Era appliance is deployed to, and you can see what version of Era you are running. If we go to the databases screen here, you will see the detail behind the Postgre and the SQL Server that I referred to earlier. Let's click through to the SQL Server source database. So you can see here we have ERP database. It is 15 gigs in size. It's running on a SQL 2016 instance. It's residing on SQL VM 01, which we have created on our AHV cluster, running Windows Server 2016. Let's jump onto that VM quickly. On our ERP database, we have created a transactions table, and we have a job that inserts a record into that transactions table probably every second or so. This is going to be used so that we can show you that we are able to restore this database to a specific point in time. So let's select the top records from that table. As you can see, ordering them by transaction ID, let's rather select the top 10 here. We keep selecting the top 10, you'll see that we are inserting a record every second or so. And that time there is just the current system time from the operating system. Jumping back to Era, you can see that we have created what we call a time machine with the gold SLA. That time machine is effectively allowing us to go back in time based on our SLA for this database. We could then clone this database to other database servers to any point in time that the time machine allows for. You can see that this time machine has existed for just over 2 months. The last update was a few seconds ago. The next time that we will catch up the database logs is in the next 30 minutes. And the next time we take a full snapshot of this database will be in 13 hours time. We also see that we have one clone of this database time machine in the environment at the moment. We have one authorized database server that we can clone to, and the gold SLA is the SLA that it's applied. An Era SLA basically defines the sliding windows that we're able to recover to. So for example, the continuous snapshot retention allows us to recover to any point in time. to any second within a 30-day retention window, and that period will slide as time carries on. Daily snapshots allow us to recover to our daily snapshot that is taken, and we will retain that for 90 days. Similarly, we can do the same for weekly, monthly, and quarterly snapshots, and we have different intervals defined for those as part of the SLA. These SLAs are completely customizable. You can even create your own. If we jump through to the time machine details, we get a visual representation of our SLA. We have a calendar view here that allows you to click through to specific dates, and it'll show you the recovery possibilities that you have from this time machine. So as an example, the green is a representation of the continuous period that we had, that sliding 30 days that we have. So you'll see the 11th of January back to the 13th of December is that 30-day period where we can do a point-in-time recovery. In order to clone a database to a server, we need to register a new server in Era. So let's jump through and do that quickly. We're going to register a new SQL server, and this will be our SQL VM03 that we created with Calm earlier. We specify the credentials to connect, the version and the instance name, that we're using Windows authentication, and then we will go ahead and register the database server. Speeding up time again, you'll see that Era takes around 7 minutes or so to register this new database server. During this process, it's deploying a bunch of scripts and capabilities within the VM itself. To verify that that's completed, we can go and see that we have one server that's not in use at this point. There it is, SQL VM03. We click through, and we can see all the properties around that VM and that database instance. We need to add that new SQL instance as an authorized destination or an authorized database server for the time machine. So we click through to authorized database servers, we select VM03, we move it across to the allowed machines, and we click update. That SQL instance is now an authorized destination for clones from this time machine. So let's go ahead and clone a database. So we will go and select a point in time. Let's look at doing it from the 9th of January. And let's select a time, let's say 2 p.m., 2 minutes and 9 seconds. Remember that time because we're going to verify that once the clone is completed. So we're going to use an existing server, so the one we authorized earlier, SQL VM03. Click Next. You can specify the clone name, which Era uses to identify the clone, and a description, all for internal management within Era. ERPDB is the name it will be restored as, and the instance name will be MSSQL Server, so the default SQL instance. Let's click Clone Database. And again, we will speed up time here because this process will take a couple of minutes. So we click through to the status of the operation, and we're speeding up time now. It's completed in about 3 minutes and 33 seconds, as you can see there. That's the last status update there. So let's hop onto our SQL VM03 and verify that the database is there. So there you see, we've refreshed, we have the ERP database present. Let's write a little query to check that our transaction point in time is correct. So we're going to take the top 10 records from the transactions table, and we're going to order them by transaction ID descending. And you will see that we come to the point in time that we expect. So 140208, which is very close to that 140209, which we specified earlier. That is the frequency that we are inserting those SQL records on. Jumping back to the Era dashboard, we go through to our databases. We can now see that we have 2 cloned databases from that source database, and we're seeing a 2x savings. That's because of the use of the Nutanix storage fabric for 0-byte based clones. Looking at one of the clones more closely, you can see that firstly the size of it is 0. This is our latest clone here. You can see that it resides on SQL VM03. And there's a little bit of information around the actual space utilization for the cloning process. That wraps up the demonstration, folks. We utilized Calm to deploy a SQL Server with some customizations, and we then used Nutanix Era to clone a database from a source to our new virtual machine and new database instance. Thank you for watching. Goodbye.